Determine Z and Y parameters for the circuit shown. So don't think that this looks like a complex. It is very easy. So I will tell the procedure. There are three meshes are there. So always remember this current is I1, V1. Input side is V1 and I1. So arrow mark of the current is right side only. And output side should be always V2 and I2. And this current should be like this. So right current direction clockwise here. Here anti-clockwise. In the mesh analysis, everything we write clockwise. But in the two-port networks, output side current, it is entering here. So you have to write I2 like this, I1 like this. And this you can write clockwise or anti-clockwise. That is left to you. Clockwise or anti-clockwise. Here we are considering I2 as anti-clockwise to map with this correction. You can write I3 clockwise also. But when you write clockwise I3, I3 value will be equal to minus of this. Or you can take anti-clockwise only. And you can write I3 is equal to V3. So let us find out this. Okay. Apply KVL for mesh 1. Start from here. Apply KVL for mesh 1. So I will write here plus minus. It's a voltage source. Diamond shape means it is a dependent source. Its value depends on current 3I2. So it is a current dependent voltage source. So for I1, this is the current direction. Similarly, we have another current source here. Two dependent sources are there here. This is current source whose value depends on 2 times V3. V3 is here. V3 is here. So this current value depends on voltage across this. So for this I2 direction is this. Current is also like this only. And for this I3, this is already current source. And it will flow like this. Okay, let us write KVL for mesh 1. This V1, this voltage will be equal to sum of this. V1 is equal to, okay, V1 is equal to 1 into I1 plus 3I2 plus 2 into I1 plus I2. Or you can write here, this is minus V1, 1 I1 plus 3I2 plus 2 into I1 plus I2. Why both are plus means I1 direction, I2 direction, same downwards only. And if I simplify this, V1 is equal to 1 plus 2, 3I1, 3 plus 2I2, 5I2. So this equation is correct. So V1 is expressed in terms of I1 and I2. So two parameters we already got. Two, two parameters we already obtained. V1 and V2 are expressed in terms of I1 and I2. No? So two we got. So similarly apply KVL for mesh 2. Mesh 2 is this minus 2 plus minus. I am applying anti-clockwise. Okay. I'm applying anti-clockwise minus, then here plus 2 minus plus 2 into I2 minus I3 because I2 is going left side, I3 is going right side. Okay. Plus 2 into I2 minus I3 plus 2 into I2 plus I1 plus 2 into I2 plus I1 is equal to 0. So you can throughout you multiply by negative, you'll get the original the answer. Both are correct. Okay, if you bring all the terms right side, whatever original expression was on, I modified here minus plus plus. I told no, you can consider minus first, which what you are getting minus plus plus you can write, or you can write this plus minus minus minus. You write while you're writing KVL. Okay, in each term you can consider all the plus. First one which you are going to it plus 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 or plus minus minus minus. So that is our notation. There will some will consider minus to plus as rise in voltage, and they will consider as positive, and plus to minus they will consider as drop in voltage minus. Otherwise, while writing KVL, which you are going to get first term, no? That you can write. Okay, both are correct. So V2 is equal to, if you simplify this, you are going to get V2 is equal to 2I1 plus 4I2 minus 2I3. Here in this first equation, we got 3I1 and I2. We got expression in terms of I1 and I2 directly. But in the second equation, we have to get in terms of I1 and I2. But we got extra I3. Okay. That I3 we have to eliminate. So how to eliminate this I3 is, you have to apply KVL for mesh 3. You have to apply KVL for this mesh 3. If you apply KVL for mesh 3, and you cannot apply KVL for mesh 3 because there is a current source, and we can directly tell that I3 is equal to 2V3. Okay, I3 is equal to this current value, which is 2V3. Again, I want only in terms of I1 and I2, but I don't want V3 term also. So where V3 from the figure you see, V3 is measured plus here minus here, plus here minus here, which is drop across 2 ohm. So it is equal to 2 into, it is equal to 2 into 2 currents, 2 into I1 plus I2, 2 into I1 plus I2. So V3 is equal to 2I1 plus 2I2. You substitute here. I3 is equal to 2V3 now. In place of V3, in place of V3, if I substitute 2I1, I2, it becomes 2 into 2 is 4I1, 4I2, 4I1 plus 4I2. I3 value is 4I1, 4I2. This value you have to substitute in equation number here. I3 value you have to eliminate. Here there is no I3, no need to. But in the second equation we got unknown, unwanted term I3. So by writing KVL, we cannot apply KVL for this because there is a current source. But since it is at the edge, we can directly write I3 is equal to this current only. So V3 I don't want. Again replace V3 in terms of current, where V3 is equal to drop across 2. That is 2 into current values. Two currents are coming down. So 2 into I1 plus I2. If I multiply 2 into V3, 2 into 2, that is 4 times I1 plus I2. And if I substitute that equation, you will get in this equation, if I substitute the value of I3, we are going to end up with this. So V2 is equal to 6I1 minus 6I1 minus 4I2. So this is Z21, this is Z22. So its unit is all are ohms, 3 ohms, 5 ohms, minus 6 ohms, minus 4 ohms. That is Z parameters. Once you know the Z parameters, you can obtain Y parameters by delta Z is 4 into 3 into minus 4 minus 5 into minus 6. So that is 18 we got. And Y11, remember Y11 is, for 1 you have to take Z22. Y11 Z22 by delta Z. Similarly for Y22, 1 you have to take Z11 by delta Z. And for Y12, it is same 1 2 only, but you have to put minus Z12 by delta Z. Similarly for Y21, minus Z21 only. Y21 is Z21 but minus. For Y11, Z22. For Y22, Z11 divided by delta Z for all. Y12 is Z12 minus by delta Z. Similarly, Y21 is 21 only but minus Z1 to 21 by delta. To do this, you can find Y parameters also. It is very easy. You can follow this method, or you can follow what Ganesh also explained in the class using matrix method also. Thank you.